Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. My topic for this morning will be an illustration on how to charge a battery. Of course, this is a chargeable. This is actually a solar battery. This is a heavy one. This is 12 volt, 45 ampere hour. Actually, I use this one to power up my inverters. And this is just one of my extra batteries. So, I would like to show you how to charge this one by not using solar. I just use my assembled variable DC power supply. So what I did is that I set my input voltage to my controller to 13.2 volts. Then I connected in series an ammeter which measures its current. So I know the current going into the battery. It's 0.486 amperes. This is the solar charge controller. There's a selector here. It's either that you will be using a gel type battery or the lead acid. This one here is a lead acid battery. So I set this one to lead acid battery. This is the indicator for the charging process. It's a yellow one, so when that light turns on to green, meaning to say this battery is already fully charged. But since this is still a light yellow, we are still far apart from fully charging this battery. If you would like to see the status of the charging process, how deep is the battery being charged, we'll post this one here. Okay, so actually the battery is on level 2. The battery is still half charged. Okay, then I will try to release this one. Okay, then it goes back to that yellow thing. The only way we push this one is for us to know what will be the percentage of the battery being charged. So actually, we are on the second level of the figure, right? We are almost on the halfway charge. When we reach the third figure on top, I think that's the time that the charging color will turn to green, meaning the battery is already fully charged. But it will take some time because we are only charging the battery by a small amount of current. It's 0.480 amperes. This is a good charging process. It's not the fast one. Okay, it's just like on the cell phone. If you are using a fast charging process, the life of your battery won't last long. So actually, the slow charge is better than the fast charge. Okay, so this is just to show you how we use the so-called solar charge controller, because the sun is not available. It's morning here in Los Angeles, so I just inserted or energized the terminal of the controller from a voltage coming from my variable power supply to act like my solar panel for the meantime. But just in case it's during the day, okay, of course, I will be inserting the two terminals coming from the solar panel, so there will still be a voltage like this one. Okay? For a solar charge controller to work, there should be an input voltage coming from an external power supply or from a solar panel. And the output of this one is fed to the battery. So the use of the solar charge controller is that for this battery not to be overcharged. That's why it is solar charge controller. Okay. Okay, that's it. This is how to illustrate how to charge a battery by using a solar charge controller, in which the input voltage charging the battery is not from the solar panel, it's from an external power supply. Okay? If we could maintain the voltage to be 13.2, there's no problem. But sometimes, if we are using solar panel, if the sun shines, okay, the voltage might go up to 18 volts. So if you are feeding that 18 volts to the battery without the solar charge controller, the battery might, get busted. So the main reason why we use solar charge controller if we are using solar panel is for us to eliminate the busting of the battery. Okay, the battery will be destroyed. There is too much voltage during a hot sunny day if we are using solar panel. But for this one, there's no way we could overcharge the battery because the voltage, the input voltage is just 13.2. But for a solar panel, on a hot day, that 13.2 might rise up to 18 volts. So if you are feeding that 18 volts to the battery without the solar charge controller, you will be destroying the battery. So the main purpose of the solar charge controller is to avoid the battery from being overcharged. Okay, good morning from Los Angeles. This is Professor David J. De Los Reyes.